Hi everyone, and welcome to today's video. Today's video we are going to review how to name and write formulas for binary ionic compounds. Binary means that you have an ionic compound that is composed of both a metal ion, we call that a cation, and a non-metal ion, which we call an anion. So let's write the name from the formula. The first thing we need to do is write down the name of the metal. We name that just the way it is. Then we write down the name of the non-metal, and we change the ending to IDE to the root of the non-metal element. So here's my first example. I have AlCl3. I name the metal, which is aluminum. I name the non-metal, which is chlorine, but now I add the suffix IDE to the root, and so it becomes chloride instead of chlorine. We are not using prefixes with ionic compounds, so it is not aluminum trichloride. Please try to remember that. We're going to use prefixes with another system of bonding, but not here with ionic compounds and ionic bonding. Okay, let's do another example. NaCl. So I name my metal first, which is sodium. I name my non-metal second, which is chlorine. And I change the ending to IDE for this one, so it becomes sodium chloride, and that sounds familiar to us. We've heard that before, and that's what we know as table salt. Let's try one more. I have Ki, so I name my metal, which is potassium. I name my non-metal, which is iodine, and I change my ending to IDE, so it becomes potassium iodide. And this is used in explosives. If I want to write the formula from the name, I have to do a little bit more work. I have to write down the symbol and charge of the metal, the charges you will always know from the periodic table. And then I write down the symbol and the charge of the non-metal, and I need to make them balance out to zero. We talk about ionic compounds having zero charge, or they are electrically neutral, and so I have to add enough of each kind to make them both zero. And this is where drawing pictures or the Lewis structures might help you with this too. So barium sulfide, for example, Ba we know has a +2 charge, it's in group 2. Sulfide has a -2 charge, and so these charges are going to balance out already. +2 and -2 is going to add up to 0, so I only need one of each kind of ion. And so my formula becomes BAS. In my next example, I have aluminum oxide. Aluminum, we know is going to be a +3 charge from where it is on the periodic table. It's in group 3. Oxide is a -2 charge. It's in group 6, and it's going to gain 2 electrons to get to 8 valence electrons. And then I need to do a little math here to figure out how many of each I need. I'm going to make these add up to +6 and -6. So that's what I see on each side happening. So I need 2 positive aluminum ions, each with a +3 charge. I need 3 oxygen ions, each with a -2 charge. And when I make my formula, that becomes Al2O3. And notice those are subscripts, okay? Subscripts tell you how many of each ion you have. There are no charges in ionic formulas. Please do not put charges in your ionic formulas. They are subscripts which tell you the number of ions, okay? Let's do one more example here. Sodium fluoride. Sodium we know is a +1 charge, it's in group 1. Fluoride is a -1 charge, it's in group 7, and it will gain 1 electron. And I put these together, +1 and -1 balances out to 0, so I only need one of each kind of ion, which means it's NaF. Okay? Transition metals, though, are a little bit different case. Transition metals, which we know are in the D block, are elements that can have more than one possible charge. They have 2 or more charges. And so we need Roman numerals in the name that will indicate the charge of which ion is happening, how many electrons it's giving up. Copper is one example. Copper can make a +1 and it can make a +2. It does both. It doesn't do both at the same time, but it chooses kind of which one it wants to do based on maybe what it's pairing with. So copper 1, I would put a Roman numeral 1. Copper 2 plus, I would put a copper Roman numeral 2 to indicate the charge. So the Roman numeral indicates the charge. Iron is an example of an element that makes a +2 or a +3 charge. So I need Roman numerals 2 and 3 respectively to indicate the charges on those ions. Again, we've said, yes, that Roman numerals you need to indicate the charge, and there are a couple exceptions to this. Silver is an exception. Silver always makes a +1 charge, so you don't need Roman numerals with that. Zinc always makes a +2 charge, and cadmium always makes a +2 charge. These are exceptions that you will need to know and have memorized. Otherwise, you'll be able to figure out the charge of the other kinds of ions down below. So down below you just see some examples of the charge of the ion and how it's named. So I see iron 3+, which means it's iron Roman numeral 3. It's copper +1, which means it's copper Roman numeral 1, etc. You remember you can pause the video at any time and study these examples. On the next few slides we'll go through how to figure out the charge, but for right now we're just noticing that the Roman numeral is the same as the charge of the ion, not of the subscript. Okay, so let's figure out how we can know the charge of the transition metal from the formula. So the first thing that I want to do is to draw the picture. I have my formula FeCl3. I don't know the charge on iron, but I know that there's one of those ions. My subscript is 1, so there's just one iron ion. I see a 3 next to the chloride, which means there's 3 chloride ions, and each of them have a -1 charge. So my charge on iron, when I add it to -1 and -1 and -1, has to equal 0. So iron needs to have a +3 charge. So my name of my compound is iron Roman numeral 3 chloride. If I look at another example, CuCl, my picture says that I have one copper ion, I don't know the charge on it, but I have one chloride ion and I do know the charge on that, it's -1. So something plus -1 equals 0. In this case, copper is a +1 charge, so it's copper Roman numeral 1 chloride. Let's do a few more examples. So I'll switch over to my document camera here, and let's do this first example with CuO. I want to draw the picture. The first question I should ask myself is, does it really need Roman numerals in the first place? Copper, we know, is a transition metal. It's not one of my exceptions, so it's probably going to need Roman numerals. So if I do copper, and I don't know the charge on that, but I know there's one of them, and oxide, there's one of those with a -2 charge. So something plus -2 has to equal 0. So copper, that's a +2 charge. So my name is copper 2 oxide. Okay? Let's look at this second example, SnO2. You can pause the video and try this one on your own, and when we come back, I'll give you the answer to it. So here's the explanation. SnO2. Sn, we don't know the charge on, but I know there's 2 oxygen ions, and each of them has a -2 charge. So something, all together, that's a -4 charge here. So tin, there's only one of them, so that has to add up to a +4, which means this is a +4. So Sn is tin, Roman numeral 4, and this is oxide again for my name. Okay? If I name from the formula, and again, you can pause the video and try these on your own first, and then come back and go through the explanation. So iron Roman numeral 3 bromide. Roman numeral 3 is going to tell me the charge on iron. So I'm going to have iron with a +3. Bromide is a -1. And so I need to add a few more bromides to make my charge balance out to 0. I need 3 altogether. So my formula for my compound becomes FeBr3. And we'll do one last example here. I have lead 2 chloride. 2 is the charge on lead, so Pb is a +2. Chloride is -1. +2 and -1 means I need to add one more chloride, so I end up with PbCl2. Okay? I hope that was a good review for us today on naming ionic compounds. In the next video, we will go through how to name and write formulas that involve polyatomic ions. So stay tuned.